Remember, is it? I think it's recording now.
Yeah, it is.
Yep. Thank you. All right. So.
What are you doing first?
It's the 8th, correct?
What? I think it works now.
Okay. So first of all, let's just talk about in general, if you would look in your book, there is a picture in 9-3 with die. 2 dice, actually. Let's take a look at that first. Page 719. And so when you're rolling 2 dice, then first of all, if we're doing probability, it's really about counting. So we're counting the successes or the way the successes or the outcome could happen, please, over the total number of outcomes. So if you are rolling a die, there are 6 possibilities, correct? So if I'm rolling 2, how many possibilities? 36. 6 times 6. Multiplication counting principle. So then you might be asked to count ways that, I don't know, what's the probability you would get a sum of 5? Well, we know that of 5. We know it's going to be out of 36, right?
What does that say? All 5.
Sum of 5. Okay, so I need to count all the ways I could get a sum of 5. So on the first, I'm going to just go through. We know it's out of 36. What if I got a 1 and then a 4? Okay, that would work. A 2 and a 3. A 3 and a 2. Now notice those are not the same thing because 2 different, yep, 4 and 1. How many ways can I get a sum of 5?
5 and 0.
There's no 0.
So there were 4 ways that I got a sum of 5. We know there are 36 possibilities because 6 times 6. So the probability would be what? Or 1/9. Okay. Does that make sense so far? Just basic probability that you've probably learned about in algebra. Some things that we need to remember today, if we are talking about how to find the probability of some kind of event, in general, it's going to be the number of outcomes in the event. That's what I was just doing. I was saying, hey, my event was sum of 5. Number of ways I could get a 5, and then I counted them. And then on the bottom, number of outcomes in the sample space. And I'll tell you what a sample space is in a second. The sample space is just all possible outcomes. So really we're going to be using methods of counting. Okay, tell me what you know about probability. Can it be greater than 1? No. So when I'm talking about probability, the probability of an event, I'll write probability of E, has to be greater than or equal to 0 and less than or equal to 1. What does a probability of 0 mean? No chance of happening. For instance, if I said, what's the probability you get a sum of a 1 in this scenario up there? 0. Couldn't happen. Okay. 1 is the probability got a 100% chance of happening. So if I said, what's the probability you're going to get a sum that's an integer? You're going to, right? Because you're dealing with things that are all integers. 100%. So if you are adding the probability of an entire sample space together, it has to equal 1. Otherwise, it's not valid. Does that make sense? Okay. So, for instance, I don't think we have to write this down, but if you flip over the page to 720, you are given the total outcomes for all the sample space of the two dyes. Do you see this down on the bottom here?
Yeah.
So this is the sum of a 2, 3, 4, 5, 6. Those are all the possible outcomes for the sum of the two dice. Okay? And these are all their probabilities. And if you would add those probabilities up, they would equal 1, because the total sample space has to have a probability of 1. So sometimes I'll ask you, is this a valid probability distribution? And that's just a fancy way of saying, does all of the probabilities in the set equal 1? And if they do, then it's valid. If they don't, then it's not. Okay. Questions so far? All stuff that you kind of sort of know, I hope? No? Yes? Maybe? Okay, let's talk about some donuts. Yeah.
Donut graph things or like a third one kind of
Nope, it's not a donut graph. We're really going to talk about donuts. Okay.
probability of
Suppose Heidi
each plate 12 dozen donuts.
buys a dozen donuts.
I like that.
She's going to share, though.
Maybe not.
Heidi buys a dozen donuts. She offers,
No, I offer myself.
Cole's being nice, so she offers Cole 2 donuts. What are the chances so we're assuming that they're in either a bag or a box. What are the chances he pulls out 2 cream-filled donuts if 5 were cream-filled? We don't really care because I could give you all of them. There's an M&M problem or a chocolate candy problem in the homework today. Okay, so she's got donuts. I picked cream-filled because let's just say they all look like the round. You can't see them, okay? So you can't tell what's in the middle. We're just going to pretend for the sake of this problem that he doesn't really know, or maybe he's just reaching into the bag of dozen donuts and he's not looking, okay? There are 2 ways you can think of this problem. You can think of this as a combination, or you can think of these as multiplication counting principle. Okay, so the first way is I want to know how are the number of outcomes of 2 cream donuts. And on the bottom, number of outcomes of just 2 donuts. The difference between those is on top, I'm only choosing, because I'm only measuring how many cream-filled he's going to have, and the bottom, I have to put, what are all the different possibilities for donuts he could have. Hey, who do you need? Some people are gone for the field trip. Maddie? Yeah. I know, you're not saying it.
Thank you.
You're welcome. Okay, so the way that we would do this is a combination because we don't really care the order that the donuts are. He's just picking 2, 1, 2. So how many cream are there from him to choose? Are there from him to choose? 5, and he's choosing 2. So I would write that 5C2 and total 12C2. Okay, so what do you get for that? Isn't 5C2 10? 10 out of 66. Okay, well, let's keep going. Let's reduce this as a fraction, okay? So if I reduce this, it would be 5 over 33, correct? Okay. So, now, let's do this with multiplication counting principle. And I'm going to treat this as independent events. I'm going to show you that they're the same. So I'm going to say Cole reaches in, gets the cream filled. Cole reaches in, gets the cream filled. It's two separate events. So we are going to multiply the probability together. So I'm going to count them each individually now. On the first try, what's the chance he's going to get a cream-filled donut? 5 out of 12. We're going to assume that he did get, because this is what I'm measuring, we're going to assume that he did get a cream-filled donut. So there are no longer 5 cream-filled donuts. There are now 4 out of 11. So when I look at that, I get 20 over
32.
which is
22. 5 over 22.
hold on. Isn't it the same? Shouldn't it be the same?
Yeah, that's what I'm saying, 5 over 22.
5 over 33, you mean?
33.
Okay.
I'm blind.
Okay. So there are kind of two ways that you can think of that. Okay? Okay, how are we feeling about that so far? Good. Okay. Then I'm going to show you one last way to display a probability distribution, and that is a Venn diagram. So, Venn diagram. Yay. Okay. So my scenario for the Venn diagram is, let's say in a high school, I'll abbreviate, 54% of students are girls. I'm not going to state that. 62% of students play sports. Half of the girls at the school play sports. Okay, write down that scenario, and then we're going to do Venn diagram. And we'll just answer some things about that. Okay, so the two categories that I'm comparing here, that doesn't mean that those are the only two categories. The two categories that I've given you information about are what though? Girls and kids, the percent of students who play sports. So I'm going to do one circle over here, and this is the girls. And then I'm going to do another circle over here. They're going to overlap. And this is the students in the school who play sports. And then I'm going to put a rectangle around that. Okay. So, first of all, what does this area in the middle represent? The girls that play sports. Okay, so we're going to put some percentages in here. This entire circle is what percent of the student body? 54%. But how can I figure out the percent that's over here, which would be girls who don't play sports and girls who do play sports?
We don't have 100, so like 54,
It would be the other 50% of girls that don't play sports.
Which would be what percent?
22.
27. If 54% of the students are girls, they have to be split equally in those who play sports and don't, because I was told half the girls play sports at the school. That would make this probability 0.27 and this probability 0.27, which is great because I need this